Hey everybody, this is Alex Merced, and this will be the first in a series of videos going over how to work with data frames using polars. Okay, polars is one of the popular Python data frame libraries. Now, just to kind of give you some context on this, if you haven't seen my What is a Data Frame video from before, a data frame is just a data structure that's optimized for analytics in the sense, and then what makes it optimized for analytics is that instead of storing the data in rows, so for example, instead of doing this, name, age, not forget an ID column. Okay, and then storing the data like so. 1 Alex 38, 2 Tony 35. Okay, so see, this would be great for transactional type operations where I'm adding a row, subtracting a row. So think about using your typical application that adds a user, subtracts a user, that user makes a post, deletes a post. These are transactions, and row-based structures work really well for that kind of work. But when you're doing analytics, not as much. In this case, you would prefer sort of this structure. Okay, instead you would have essentially ID 1, 2, name, Alex, Tony, age 38, 35. And the benefit of this is what's referred to as a columnar structure. And the benefit of this is that it's much easier for me to do analytical operations. Because, for example, I might just be asking what the average age is, in which case I really don't need the IDs and I don't really need the names. I just need what's here. Okay, so it's very convenient for me to just pull that single column out and do my mathematical operation on that column. Okay, versus me having to read both of these rows just to get the number in both of those rows. So it's just more efficient from a computing processing standpoint. And again, that means you can get things done faster, and faster generally means cheaper because compute power, you pay for time. Okay, so faster is cheaper. Okay, so in Python, there are several different libraries that allow you to work with data frames like this. Okay, probably the most well-known one is pandas. And pandas, basically, again, you have all these like arrays or columns. Okay, these columns tend to be an array of values. In pandas, these arrays are generally represented using NumPy arrays. Okay, now NumPy was a library that tried to make more efficient arrays than what Python natively made available with using the list data structure. Okay, because that's essentially a linked list, which isn't as fast as like a sequential block of memory of, same data type. Okay, so NumPy kind of created a implementation of that, a much faster arrays that pandas then leverage to construct its data frames. Okay, and again, these are all data frame libraries. Okay, but if you've seen my video on what is Apache Arrow created a standard way across all languages to represent columnar structures in memory. That's really, really, really fast. So basically, another data frame library was created using arrow constructs. So instead of using NumPy as its underlying array data structure, it uses arrow structures. Okay, and this library is called polars. This will be what the focus of this particular series is. And basically, it's able to get speed performance benefits by doing so, and it's become quite popular and is usable in many different languages because it's using that standard format. Basically, that polars data frame library can then be re-implemented between languages without necessarily changing how it works. Okay, another interesting project is IBIS. IBIS, basically, the idea here is you would use IBIS as your data frame library, and then IBIS can then take those data frame actions and then send them to a variety of databases, and query tools. So essentially, IBIS acts as an intermediate for what typically would be like SQL databases and data lakehouses. Data lakehouses and data warehouses, it provides sort of a uniform standard data frame library, and then any SQL database, data lakehouse, data warehouse can then build a backend for IBIS, so that way it can translate that IBIS code to directions to their engine. So that way you can take advantage of any query engine that does like distributed computing that doesn't necessarily have its own built-in data frame library or data frame interface. You can use IBIS, which is pretty cool. Okay, and then the last one I'll point out is PySpark. Okay, which the purpose of PySpark allows you to write Python that leverages Spark. Okay, and again, Spark is written in Java. But essentially, they've basically re-implemented their SQL and Dataframe APIs through PySpark, so that way you can send those same exact directions. Essentially, the PySpark gets translated into the Spark API to communicate with those servers, and you're able to send jobs and requests to an Apache Spark server to get job done on an Apache Spark cluster for parallel processing. So essentially, this is sort of like the world of like Python data frame libraries. Again, there are other languages like R and Java and whatnot, which I'm not talking about the data frame libraries in there. Although Polars, again, because it's very standardized, does exist across many languages, which is why I'm going to be focusing the series on that, because it makes that knowledge is going to be a little bit more portable. Okay, across different languages, and plus Apache Arrow is pretty much the future of how we represent data. Okay, so hopefully you guys enjoyed that explainer of sort of why we're learning what we're learning. Now with that, I'm going to bring up VS Code. So we're going to reset up our Conda environment. So again, I'm using Conda. You could do this with Conda or pip. I'm just using Conda because it's more of what data people use. But pip is fine. I use pip all the time. But essentially, what you're going to want to do is that once you have your Conda environment going, which again, you can just do that by, if you followed my intro to Python video, you should already have a Conda environment called myenv. So you can just activate myenv or whatever virtual environment you're using. Now, if you're using Conda, I had an older version of Conda, so I had to manually add the Conda Forge repository. So this would be the command if you need to do that, because otherwise I wasn't able to actually install Polars because of the older version of Conda that I had. But once you have that, you can just do Conda install Polars, also install Seaborn. Seaborn is going to be a library we'll use for generating charts later on in the video series. And if you're using pip, you can just install Seaborn and Polars and you're good to go. But once you have that installed, we can start our Jupyter server. So I'm starting my Jupyter Lab server. And again, I'm doing this in the repo that I have for this channel. So you'll be able to find all the videos in the intro to Python folder. Okay, or all the notebooks that we'll create here. Okay, so I'm going to start up Jupyter Lab. Server's running. Jupyter Lab is opening up. Okay, awesome. And I'm going to go back to this here main folder. I'm going to create a folder called, we're going to call this Polars exercises. Okay, now in that folder, we'll create our first notebook. Let me just close this one up. Okay, create our first notebook, Python. Okay, we'll rename this notebook. Actually, I think it's just right-click it here. Rename notebook, and I want to rename this Intro to Polars. I will just show you sort of the basics. Okay, so bottom line is you first want to import Polars as PL. Okay, so that's essentially the first line. That's just generally the standard way of bringing in Polars. Now what we're going to do is we want to create a data frame. So right now we're just going to manually create a data frame. We'll load up files in future videos. But just to create a manual data frame, essentially what you do is we'll create some data and we'll do it as a dictionary. And the idea is that you'll have one property per column. So to recreate that data frame that we had at the very beginning, I would have an ID column. Okay, and then I would pass in an array of the values. So in that case, that was ID 1 and 2. Then we had a name column. And I would then pass in an array there of the names, Alex Tony. And then we would have an age column, which would be 38 and 35. And then what we can do is we just say, hey, we're going to create a data frame, so df for data frame, and that's going to equal pl dot data frame. And then we just pass in that data, and that'll turn it into a data frame, and that's going to give us all the Polar superpowers. And I can just basically see that data frame by just printing it. So I can just print the data frame, and we'll be able to see the data frame in action. Okay, awesome. So you see, there we go. But again, it's essentially an array of columns. Okay, and that's the structure of a data frame. Cool. So now you see how the basics. In the next video, we'll kind of get deeper and start doing some more fun stuff with these data frames. But I'll save that for that next video. So I'll see you there. I'll come see you then.